a very technical presentation, basically, but I tried to make it as simple as possible. The whole idea is that this thing of disaster-resilient schools is something which is very much needed in the Philippines. No? So, I'm going to go through my presentation this way. I'll talk about what we are, because I think this is our first exposure to a multi-sectoral group. We'll talk about the competition which we launched, which came up with the ideas of disaster-resilient school. I'll cover in detail the winning entry, which will actually be built. And then we'll cover other interesting design disaster-resilient strategies in the other entries, and we will close the thing. I'm given only 15 minutes. Okay, it's 5:10. What are we? We are the Green Architecture Movement of the UAP. No? We were started in 2000, and because of the need to continue our advocacy, we decided to reform ourselves as the Green Architecture Movement. And the reason why we're pushing it very hard is because, admittedly, 50% of all the energy usage in the world is due to buildings. So we are the guilty parties, and that's why we're trying to offset our effects on the world. No? I have a co-member of the Green Architecture Movement, Architect Casus, there in an orange shirt, so you can see him very easily, and white hair. So our mission statement is very simple. LIA, learn. We try to learn the principles of green architecture because every day there's always something new about green architecture. Second, we inform the architects as our primary objective, and then we inform the public in general. So we have actually several sessions on that. And then we apply green architecture principles in our practice. Project modules, well, we have continuing education for members. We have a green forum every year, which the public is invited. This year, we're holding it on September 4 and 5 at SNX. It's an open seminar. We talk about green architecture, etc., etc. No? Okay, now we start so that I can get the most out of my 15 minutes. We see this thing every year. Houses being blown by typhoons. We know that typhoons are going to hit us every year. Yet, every year, the same story. Houses get blown. Where do they go? Evacuation centers, which are supposedly the schools. These are the schools. Every year, the same thing happens to the schools. It's blown away, and they are supposed to be the evacuation centers. So that's why, because of this cycle, we decided to look at something, the competition. Every year we know that typhoons are going to come. It's inevitable in our country. The typhoons bring about destruction. We rebuild. But what are we rebuilding? We are rebuilding exactly the same structures which we built before the typhoon, knowing very well that it will be blown away the next year. And we go to the whole cycle. In this to the public one time, somebody mentioned to me in private, negosyo yan. Siyempre, pag may sorry, they're foreigners. It's a business. Okay? So if there's construction every year, money moves, right? So I said no. But as a group, we decided no, we're going to change this. So there was a group called Be Better, Build Better. It's a project in which we try to break this vicious cycle of calamity, destruction, and rebuilding cycle. So the partners are following, and National Disaster Coordinating Council, DepEd, Department of Public Works and Highways, the private sector, Disaster Management Network, I don't know if they're here, My Shelter Foundation, Philippine Green Building Council, Red Eye, which actually promoted the thing, and us, the United Architects of the Philippines. Of course, part of this thing, the first step was to do a school. Why did we start with the school? Because they're the evacuation centers. Let's see, first fix up the evacuation centers and the schools before we move on to the houses. So we created this competition. We called it the Millenium School Competition. And the criteria was this, very briefly. First, we decided let's have a design-build competition. Not only a design competition, because sometimes people join design competitions not worrying how it's going to be built and leave the headache to the people who are going to build it. So we said, you win it, you design it, you build it. Okay, so that means if you're going to design something, make sure it's going to stand up. Second, we opened this thing to all architects all over the world. Anybody who wanted to come in with their ideas on how to design a disaster-resilient structure. We had 7 criteria. Number 1, innovative construction technology. In other words, if you do it at standard school building, which looks like any other school building, you're out. Okay? Innovative, something new, something different. Second, it had to be cost effective because the target which we're looking at was a public school. Third, sustainable site and building. Well, because we're the green architecture movement, we try to make sure that that whole school was going to be sustainable. Fourth, the most important factor in the Philippines is typhoon. Okay, this happened, so that's the most destructive. Fifth, earthquake resistance. Sixth, flexibility of use. That school building can be used as a school and at the same time should be used as a evacuation center. And lastly, 7, adaptability to other sites. In other words, you can replicate that concept anywhere else in the Philippines or anywhere else in the world for that matter, which have the same conditions. So what we had to do, we asked them, the competitors, was first design the master plan of a school, then detail 1 classroom building, and then they were supposed to submit the following boards. Huh? So, what site did we choose? We picked a site on the eastern shores of Camarines Sur, in a small town called Sagnay, and a small school called Nato Elementary School. So this is the site. Okay, we came in because of the typhoon. There was 4 classrooms which were in this condition, and before the DepEd was starting to rebuild, we said, okay, wait, reserve that site for us and for our competition because we're going to build the prototype in that area. No? So as you can see, the school, that's the building there, the whole school. This is how the temporary building looked like. And here you have the DepEd starting to build the same classroom they built last year and the years before, which got blown away every year. No? So anyway, we told DepEd, teka muna, reserve this site for us. So we went into this competition. Winners! Huh. Amazingly, the first place winner went to a Malaysian architect, Elida Himil, who received a prize of $10,000 US, and when she won, she donated it back so that the building could be put up. Second place from the Philippines, Bronte Top. Third place from Philippines, Nick Del Castillo. And then we had honorable mentions, Suzette Stoller from the US, John Bencerito from the Philippines, Joe Villante from the US, and Fuyuki Makino from Japan. Huh? Okay, let's look at the winner, Hamil. Elena Hamil. This was her first board, but let's zoom into the more interesting parts. Her master plan was basically a linear structure. Why? Because the property was linear. No? It's very, very, very long. So she had very simple buildings of 2 classrooms each. Why did she do that? Primarily because of that. No? The Amihan Hambagat, she put smaller clusters so that the wind can go across, and also reducing the load of the wind. If you have a very, very long structure, the wind will be much stronger and go to the sides. No? That's how it looks. The second board was this, and I'm going to focus on how she built the structure. Huh? It's quite interesting. So first thing, which we never do in the Philippines, put low piles and put a pile cap. You know these piles, I'm sure you only refer to piles when you do a high-rise building, no? These very, very heavy things. But these are very simple piles. Maybe no more than 2 meters or 1 meter. Just maybe it can be small concrete piles. And then put a pile cap. Okay, this means you're embedding the building deep into the ground, no? Especially if the building is on soft soil. Second, put a concrete slab and put a concrete framework. Beams, columns, but then notice, this is all the pipes which we're going to add later on, the bamboo. Okay, so we have a very sturdy structure, solid, reinforced concrete, and really embedded on the ground. No? Now, remember those bars here? So now where the windows were, we start putting the bamboos, and also the bamboos here. Notice one thing, the bamboos are always in 2s or in 3s. It's a redundancy system. In other words, if one of them is weakened or breaks, you can take it out and replace it without the structure coming down. A very interesting concept which we thought, that's why we said, oh, that's interesting, no? Redundancy. Next, in this area where the walls were supposed to be, he starts putting bamboo. Actually, she's later going to cover that. And then through this thing, for decorate purpose in the bamboo, she puts little circles because later on, she will cover that with concrete. No? So bamboo behind, then she starts plastering the walls, no? With little holes. Decorative lang yan. But anyway, what is that? That is bamboo reinforced concrete. Actually, Architect Casus there champions bamboo reinforced concrete for the Philippines, no? So it's something cheap, it's no metal bars, and yet that is very, very durable. Now she starts putting up the rest of the framework. Again, notice, duplication, redundancy. 2, 3, 2. Always, even these things, this is 2. Okay, the whole idea when I was reading her concept was that it's precisely if one breaks, you don't have to tear down the whole building. It will just probably get weak a bit. You can always add it later. No? So now she starts putting all the rest of the items and then puts the bamboo, it's a technical term, purlins. No? Because on top of that, she puts a GI roof, ordinary GI roof. And then finally, another thing which was quite innovative, we thought, she sandwiches that roof still with another bamboo. In other words, it's like, you know, some houses they put rubber tires on the roof, no, so that the roof doesn't fly. No? But this one is a more sophisticated, simple way. Also bamboo, strapped between the rafter here and the one on top, so it's really held in place. No? So this was how the house was, the school was going to be built. It's only a two classroom building. This is the third board where she put on her elevations. You notice it's very simple, one story. And just to zoom in, she actually did the model just to prove that how it was done. These are all lashed with nylon ropes, no? Lashing only, no nails. So they're all anchored to the pipes here, all lashed tight together. And it's very resilient, even has a cross bracing here, no? So that it doesn't move. No? It's very simple and very, very green. These are perspectives of the building. Notice that she has, in between all the school buildings, she has a clump of bamboo. Precisely because that's where you're going to get the very same material to maintain or rehabilitate your building should the need arise. Okay, so you notice it's very interesting. It's a combination of reinforced concrete, combination of bamboo, and a combination of bamboo reinforced concrete. No? It's very interesting, as you can see. No? It's very nice, very pleasant. Then even the material itself can be related to the people in the locality. In other words, it's not something foreign. Most likely their houses actually are also using the same material, bamboo. Then our concept board, we'll just focus on a few things. So again, the finished building is like this. Bamboo reinforced concrete with holes, decorative. Then we have full bamboo with gaps of about 100 mm, 4 inches, so that the breeze goes through. We have a 2-level roof, so that there's cross ventilation and light coming in, especially there, that's all open. Columns, and then we have the piles. No? So what did she say in her board, which were her typhoon-resistant principles? Number 1, although we asked for 4 classrooms, she broke it down into 2 classroom modules. So, smaller, so that in case it is damaged, the damage is restricted to one structure. Because if she had put 4, which we were requesting 4, then it would be in a bigger building. So it's smaller, you just duplicate that. Secondly, the classroom walls are actually porous. These are not windows. There are no glazed windows or glass windows. Actually, they are just bamboo with small gaps. The major light comes actually from the high ceiling. So these are the classrooms, and these are the 2 bathrooms, which also are used, should it be used as the evacuation center. No? So cross ventilation. She lets the wind through. On a master scale, which I mentioned earlier, on the master plan, you have the breeze coming through. No? In other words, breeze coming through. These are all these small pocket gardens which have the bamboos. No? Second here, she lets the breeze come through. You notice all the light of the classroom will enter through this area. And then her roof slopes are 30 degrees. I was conferring with a colleague of mine architect here there because he did a master's on disaster resilient structures. He said really for typhoon resistance you need an angle between 25 to about 45 degrees, no? So that the wind is good. So this is 30 degrees, so it matches perfectly with her findings. So I'm glad that it's there. So right now the condition of this structure is that there's a local architect who is trying to localize, so to speak, the details because the winner is from Malaysia, and we should be building it soon there in Sagnay. No? Actually, it's really far. It's about an hour's drive east from Naga City. No? Really there on the shores. No? Okay, what were the other winners? Second place, Brown Dito. Interesting concepts. Number 1, W steel frame. And the consequence of that, the walls are not straight. The walls are inclined and it is raised from the ground. Why? When the wind blows, 3 minutes. That's good, thanks. Almost finished, no word. So the wind blows, wind does not hit the wall, but it goes down and goes up. Interesting concept. Third placer, Nick Del Castillo. In disasters, in typhoons, normally what first goes are the roofs. It starts off with the little corners starting to peel off because of the wind and starts continuing until the whole roof goes out. Huh? He put a block on the roof edges. Notice? Here also. Here is raised. So he protects that. Secondly, again, same principle, although he also put all his walls at an angle so that when the wind blows, it either goes under, it's also raised, and it goes above. No? So interesting concept. This one, Joe Brillianti from the US, of course, US. Just an interesting concept. Storm boards or shutter boards. So during normal days, it's used as a media agua. And when the storm comes, you shut it down. No? This is the most interesting, although the shit wind. This is the idea of deflecting the wind above the structure. No? And the interesting thing here is this. Let's focus on this. Huh? This yellow thing could be an existing building. Could be. Ordinary building. You add this green thing, which corresponds to that, sort of to deflect. For a school building, she said this can be used as bleachers for the field. You can also pass through under here, so it becomes an external corridor. Then she adds the edge units. In other words, the interesting concept here is that you're deflecting the wind. At the same time, you can actually retrofit an existing building to be able to deflect that wind. No? So in summary, see I'm ending. Huh? What concepts were placed in those on those boards? Number 1, wind is critical. So you either deflect it or make it pass through. Second, interesting concept of sandwiching a metal roof between two bamboos. Then, protecting the roof eaves from the wind. Third, inclined walls. Because if your wall is like this and the wind is blowing, you're 50% already toppling down on the side. But if you have it inclined on one side, then you need a greater force to be able to move it or push it out of place. A steel W frame, which was shown in the second place winner. Then the concept of shutters, which can be used as storm shutter or sunshade. And then the concept of using bamboo for its resiliency and the concept of redundancy. Besides, it's sustainable because if you plant bamboo in the very same project site, then you can actually use it. And then something which I try to analyze here, the use of piles, something which we can maybe introduce to maybe low-cost structures, the concept of putting piles. No? So this was a competition for school buildings. So with this group, I don't know if you're ready for this. Maybe we should also organize, with your help maybe, an international competition for disaster-resilient housing and communities. And therefore, maybe if we succeed in that, maybe 2 years from now, I can come back and give you the results. So with that, thank you very much.